Hey, fourth graders. We are getting started with our unit on fractions, and that unit starts with equivalent fractions. So what I wanted to do is make sure that we understand our fractions vocabulary, and also I wanted to show you some really cool strategies that you can use when it comes to finding equivalent fractions. So let's get started. All right. So if I have the fraction, let's just say I have the fraction 2/4. Okay, let's start out with our fractions vocabulary. Now, 2/4, we have the top number, which is called the numerator, and the bottom, which is the denominator. All right, and those words are really important for you to know and to understand. We have the numerator and the denominator. The numerator, or the top number, stands for the amount of pieces that are shaded in. So if I wanted to draw the fraction 2/4, I would take my whole and I would split it into 4 pieces and I would shade in 2. Okay, because the numerator stands for the number of pieces that are shaded, and the denominator stands for the number of pieces that there are total in one whole. All right, now we have special kinds of fractions that we're going to see. All right, and it's really important that we understand those as well. If I have, let's say, the fraction 2/2, so that means that if I take one whole and I split it into 2 pieces are shaded in. Both pieces are shaded in. So 2/2, when I have the same numerator and denominator, that actually is the same thing as one whole because I've shaded in the whole thing. All of the pieces are shaded in, okay? So now let's go ahead and move into equivalent fractions. Now, equivalent fractions, it sounds like a really funny, fancy word, but it's really not that tricky. Equivalent has equal right in it. Equivalent fractions are 2 fractions that are equal. So let's imagine that your caretaker is making you and your sister a sandwich, okay? And so we have our 2 sandwiches. And we're going to pretend that I just drew these exactly the same size. All right. So you have 2 sandwiches. And your caretaker cuts your sandwich into 2 pieces and your sister's sandwich into 4 pieces. Now, are the sandwiches the same size? Did you guys both get the same amount of sandwiches? Yes, you did. You both got the exact same amount of sandwich, but we have 2 different fractions represented. So let's say that you eat 1 piece of your sandwich and your sister eats 2 pieces of her sandwich. Now, who ate more? Well, you might think, well, your sister ate more because she ate 2 pieces. But if you look at it, I've actually shaded in the same amount of sandwich because 1/2 and 2/4 are equivalent fractions. That means that they are equal to each other. Now, this is kind of a weird concept to understand, and what I would recommend is that you go into the 4th grade toolkit under math videos, and there's a fractions folder. And in that fractions folder, you're going to find 2 really cool resources. There's a link to some virtual fractions manipulatives that you can use and look at to see different fractions. And the fraction strips are what I would really recommend. There's also a printable fraction strip file that you can actually print out on your computer and you can use to help you when it comes to equivalent fractions. And if you play around with it, you can see if you stacked these 2 on top of each other, they take up the exact same amount of space. That means that they are equivalent. So even though this one has more pieces, the pieces are smaller. So it takes more of them to equal this, okay? Now, in your math lessons, you are going to be asked to find equivalent fractions or to determine whether fractions are equivalent to one another. Okay, so let's imagine that they gave you the fraction 3/5, and they want you to list other fractions that are equivalent or equal to 3/5. All right, we have a really cool strategy that we can use to find equivalent fractions. And that strategy is called double bubble. All right, it's called double bubble because what I'm going to do is I'm going to multiply 3/5 by double bubble. And that's going to give me a fraction that's equivalent. Now, the trick with the double bubble is what you do to the top, you do to the bottom. What you do to the bottom, you do to the top. So I have to multiply by the same thing on the top and the bottom. If I don't, it's not equivalent, okay? So I can put any number I want to in the bubble. Now, I'm gonna work smarter, not harder, and pick an easy number to multiply by, like 2. And I'm gonna put 2 into both bubbles, okay? And now I'm just gonna multiply straight across. 3 times 2 I know equals 6, and 5 times 2 equals 10. So 3/5 is equivalent to 6/10. If I have to find another fraction that's equivalent to 3/5, I'm gonna do the same thing again. 3/5 times double bubble, all right? What I do to the top, I do to the bottom. What I do to the bottom, I do to the top, all right? So I'm gonna pick another number that's easy to multiply by, like 5. I know my 5s really easily because I can skip count by 5s, all right? And I know that 3 times 5 equals 15, and 5 times 5 equals 25. So 3/5 is also equivalent to 15/25. And I could keep going. I could pick any number I wanted to. I could pick 100, as long as I do the same thing on the top and the bottom. Okay, so that's really the key. You want to make sure that you've multiplied by the same number in the top and the bottom. Now, when we're finding equivalent fractions, there's only 2 operations that you can use: multiplication or division. You can't subtract by double bubble, and you can't add by double bubble. That's not going to give you an equivalent fraction. You have to either multiply or divide. Let me show you an example of division. All right. Let's say I have, division's a little bit trickier, just so you know, because you have to make sure that what you divide by, the top number and the bottom number, are both divisible by that number. All right, but I just want to show you one example of that. So let's say I have 3/6 and I want to use division. Well, I know that 3 is only divisible by 1 and 3 because that's the only way I can multiply. And if I divide 3 by 1, I get 3 again, so that's not going to change anything. But I know 6 I can divide by 3 too, so I'm going to do division double bubble, and I'm going to divide both of them by 3. All right, oops, I wrote that wrong. Sorry, guys. I wrote my double bubble in the wrong spot. There we go. All right, so I'm going to divide both of them by 3. 3 divided by 3 equals 1. And 6 divided by 3 equals 2. So 3/6 is the same thing as 1/2. Okay, again, this is definitely the trickier way. If you're just asked to list 3 fractions that are equivalent, I would by far recommend multiplying because that's easier. Okay, again, with equivalent fractions, we want to work smarter, not harder. And we want to pick strategies that make sense and are easy to use. Now, a lot of times you are given multiple choice questions for equivalent fractions, and that's awesome because then we can use an even easier strategy that I absolutely love. If you're not given multiple choice, you do have to go with the double bubble strategy. But when you are given multiple choice, you are going to be able to use another cool strategy that's called the butterfly strategy. And you can actually use this in the next part of our fractions as well when it comes to comparing fractions. And so let me show you how this works. Okay, so let's say I have 2 fractions and I want to know if they're equivalent. So let's say I have 3/4 and I have, let's see here, 9/12. I want to know whether 3/4 and 9/12 are equivalent. So what I'm going to do is I am going to make a butterfly. And then I'm going to multiply each wing of the butterfly. So 12 times 3, 12, 24, 36. And 4 times 9 is 36. Now I have 2 numbers that are super easy to compare. 36 and 36 are the same, so 3/4 is equivalent to 9/12. And if you have, like, let's say a select all question or a multiple choice question and you have to answer and find the equivalent fractions, you can just do this butterfly strategy with all of the answer choices, and that will allow you to find out whether or not the fractions are equivalent. So let me give you another example. All right, let's say I have to find all of the fractions that are equivalent to 2/5. Oops. Sorry, guys. All of the fractions that are equivalent to 2/5. And so I have my answer choices here. All right. And let's say that my answer choices are 3/5 and 2/4, and let's see here, 4/10 and 6/15. Okay. I have to test all of them because I said this is a select all the answer choices. So let's compare. I'm going to put my 2/5 here, do my butterfly strategy. 5 times 2 is 10. 5 times 3 is 15. Are 15 and 10 the same number? No. So A is not correct. Okay, a lot of students get confused because they see that the denominators are the same, but that is actually a good indication that they are not equivalent. Because if I've cut this into the same number of pieces, this one I have 2, this one I have 3, that's not going to be equivalent. All right, now here we have another one that students get really confused on. We have the same numerators, but that does not mean that those fractions are equivalent. In fact, again, it's probably a good indicator that they're not. So we have 2 times 5 is 10. 4 times 2 equals 8. 10 and 8 are not the same number, so that's also not an equivalent fraction. Now we have 4/10. And I'm actually going to write it over here, again, just a little bit bigger because I'm getting a little bit crowded over here. All right, so draw my butterfly. 5 times 4 equals 20. 10 times 2 equals 20. 20, 20. Those are the same, so 4/10 is equivalent. But remember, this is a select all question, so even though I found one answer choice, I have to test all of my answer choices. So again, I'm taking 2/5 and I'm comparing it to 6/15. And it doesn't really matter which order you write them in when you're doing the comparison. All right, so I am going to do my double bubble. Now, I happen to know that 15 times 2 equals 30, but if I didn't, I could do really quick multiplication here. 2 times 5 is 10, carry the 1, 2 times 1 is 2, plus 1 is 3. So 15 times 2 equals 30, 5 times 6 equals 30, 30, 30, those are the same. So 6/15 is also equivalent to 2/5. Okay? Now, this is, again, a really easy, quick strategy, and students seem to really understand it, and that's why I really like it. And you can use it for comparing fractions as well. So if I wanted to see, like, which of these is bigger, well, 15 is bigger than 10. So that means 3/5 is greater than 2/5. Here, 10 is bigger than 8, so 2/4 is greater than 2/5. Okay, so we can use that to help us to compare fractions as well. And like I said, that's the next unit or the next set of lessons after equivalent fractions. So both of these strategies will work. This one will work on any fractions questions where you're asked to compare or find equivalent fractions, and it gives you answer choices. Now, one thing I want to caution you about is you will sometimes see questions where you see pictures to represent the fractions. So it's not listing 2/5, 3/5, 2/4, 4/10, and 6/15, but it actually has picture models of each of those. And what I see students do a lot is just look at the pictures and kind of eyeball it, all right? Sometimes that works, sometimes that doesn't. They don't always draw the pictures the same size, and some fractions are really close to each other, but they're not quite the same. For example, 2/3 and 3/4. Now again, I'm not perfect at drawing, but let's imagine that I'm drawing two exact same size circles. And I split this one into 4 perfectly even sized pieces. See, that's not even close. Let me try that again. All right, pour 4 perfectly even sized pieces and this one into 3 perfectly even sized pieces. And I shade in 2/3 of this one, and I shade in 3/4 of this one. Now, if you eyeball it, it looks like I have about the same amount shaded in, especially if my picture were a little bit more accurate, like there. All right, it looks like I have about the same amount shaded in. But what I always tell students to do is to figure out the fractions represented. This one is 3/4, this one is 2/3. And then do the butterfly strategy with the actual numbers to make sure. Okay, you could eyeball that and say, yeah, those are equivalent, or no, those are not equivalent, but you aren't positive until you've actually done the math. You've done the numbers to find out. 3 times 3 equals 9, 4 times 2 equals 8, so 3/4 is actually greater than 2/3. They are not equivalent, okay? And so those are just some strategies, again, in that folder in the 4th grade toolkit under math videos, which is where this video is going to be housed. Under fractions, you're going to see some other tools. I've created a PowerPoint with just some sample problems that you can use to kind of practice the concepts that we've gone over in this video. There's 3 sample problems that are very common equivalent fractions problems. And then there's also your fraction strips and a link to the virtual manipulatives where you can look at the fraction circles and fraction strips. And as always, please reach out to your math teacher if you have any questions. We will be going over this in our first PLGs, but those aren't going to be until February. So we wanted to make sure that you had access to these strategies beforehand so that you could go ahead and start practicing them as you're going through your lessons. I hope you have a wonderful rest of your day, and we will be talking to you again soon. All right, bye.